Now starting with the second problem of cycloid. A circular plate of diameter 60 mm rolls without slipping along a straight line inclined at 30 degrees to the horizontal. Draw the locus of point of its contact with the line if it completes one rotation. Name the curve. Okay. Now compared to the first problem, in first problem that circle was rolling along a straight line, but here it is rolling along a straight line but inclined at 30 degree. That line is not horizontal now, so the circle is rolling along an inclined line. So first we need to draw that inclined line, which will be the directing line for that rolling circle. So initially first I'll draw the horizontal line for measuring that angle for inclined line. Okay, that straight line is inclined at 30 degree. So I'll first mark that 30 degree line, and this 30 degree inclined line will be the directing line for circle. So this inclined line is nothing but the directing line. So circle is going to roll along this inclined line and not along the horizontal line compared to the previous problem. So this angle I can say theta 30 degree. Now initially for initial position of the circle, we need to first draw the perpendicular to this 30 degree inclined line at the initial point. Okay, and on this perpendicular line to the inclined line, I have to mark the diameter of the circle. Okay, so here the diameter is 60. So I'll mark the length of diameter here. At the same time, I'll also mark the radius, which is 30 mm. So I'll mark the center for the circle. So now taking the radius in compass, I'll draw the circle. So this will give me the initial position of the circle. Okay, and this circle is going to roll along the inclined line. So the procedure will be similar to the previous problem. So instead of drawing along the horizontal lines, we are going to follow inclined lines. So first step is to divide the circle into some equal number of parts. So last problem, the diameter was 50 mm and we have divided that circle into 8 parts. Here the diameter is 60, so we can go for 12 parts for more precise curve. So now I'll divide the circle into 12 parts. So for that, by drawing the diameter of the circle parallel to the inclined line, I'll get 4 divisions on the circle. So obviously each angle will be 90 degree. So now if I want to divide this circle further into 12 parts, so each angle should be 30 degrees. So I'll mark 30, 60, then 90 is already marked. So again I'll mark 90 plus 30 will be 120, then 150. So we are marking in only one half. So producing from the center will mark the divisions automatically on the other half. Since the diameter is bigger, we are dividing into 12 parts for more precise curve. So this is one division. Again, so from the division mark, we are dividing the circle into 12 number of parts. The next part is, after dividing the circle into 12 number of parts, the next step is naming those divisions. So we have already done in the last problem. So initially, first we have to decide the initial position of the point. Draw the locus of point of its contact with the line. Okay, means initial position is given point in contact with the line. So initial position is this. So I can start naming from here P. So next division I will name 1, 2, 3, 4, 5, 10, 11. Obviously 12 will coincide with P again. Okay. Now the next step is I have to mark the length equal to the circumference, because it is rolling for one complete rotation. So the distance traveled along this inclined line will be circumference of the circle. So we can again calculate the pi d distance. So it is 3.14 into 60. So it will give me 3.14 into 60 is giving me 188.4. So pi d distance I am getting it as 188.4. But obviously it is not possible to take distance in decimal here. So for convenience we will take it as 188 mm. So approximately 188 mm. But this distance we have to mark not along the horizontal line but along the inclined line, because circle is moving along inclined line. So we'll mark that distance equal to 180 mm, which is nothing but the circumference pi d. So here it is 180, then 185, then again 3 divisions. So I'll get 188 somewhere here. Okay. So that will be the final position of this point P after one complete revolution. So I'm marking P dash. Okay. Again we will do the same method here, dropping the perpendicular from P dash to mark the final position of circle. So dropping the perpendicular here, that will become the diameter for the final position, and along that I am going to measure the 60 mm length, which is the diameter of the circle, along with the midpoint, which is 30 mm. Now we can draw the final position of the circle in advance. So final position of the circle will be here after covering one revolution. Now the next step is to divide this directing length P to P dash into same number of parts as that of a circle. As we have divided the circle into 12 number of parts, so I need to divide this distance 188 into 12 number of parts. So you can check it on Calc whether it is exactly divisible. No, it is again in decimal. So I need to again follow the acute angle method. So we have already drawn this acute angle method. So I can mark those divisions. So now here I need to mark random divisions but 12 in number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and one more division 12. For that I need to produce this further. Okay. So as per the acute angle method, I should join the last division with the end point of the original line which we want to divide. So here I'll be marking joining this length. Obviously there is no need to draw all the parallel lines. After drawing one or two lines, we can carry forward the same equal division as we have did in last problem. So we have marked first parallel line, then again I can mark the second parallel line. Now we have got the equal divisions, two equal divisions. We can verify by taking the same distance in compass. Okay, so those are the equal divisions. Now I can take the same distance in compass to mark the remaining divisions. So no need to draw all the parallel lines. So I can mark all the remaining division with the same distance in compass. So obviously your last division should coincide with P. Yeah, slight difference is there, that is acceptable. Okay, so now I will name those divisions. So starting with P, we have already marked 1 2 3 4. So this division I can mark 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7, 8, 9, 10, 11, and obviously 12 dash will coincide with P dash. Now the next procedure is to draw the horizontal line, not horizontal, now in this case it will be inclined line parallel to directing line and passing through the center. So I have to produce this line horizontal diameter. Okay, so obviously the center C is going to move along this line only. So now the next procedure is to project these divisions 1 dash 2 dash up to P dash up to the center line to mark the new positions of circle center when the circle advances by 1/12 of a division. So from each division I will mark the new position of the circles up to the center line. Since we have marked 12 divisions, so it will take more time, but we will get more precise curve. So be careful while drawing these parallel lines because they are not exactly vertical, they are inclined lines. Okay. So now we have to name these new positions of centers. So I'll start with C1, then C2 because from C2 dash, C3, C4, C5, C6, C7, C8, C9, C10, C11 up to C dash. Okay. Now the next step is to draw the parallel lines from each division to the directing line. So from directing line, I'll start with first division. So first division obviously will coincide with 11th division. Okay. Then 2 and 10. And 3 and 9 already drawn, which is the center line for the circle. Then 4 and 8 horizontal line. Then 5 and 7. And the topmost is 6. Okay. Now we know the next procedure, that is taking this distance CP, which is the radius of circle. Now after 1/12 division, C will shift to C1, but the C to P distance is not going to change. But as position of C is going to change, position of P will also change, and new position corresponding we are going to name it as P1. So with C1 I need to mark an arc on a line passing through first division on the circle, that is 1, and above P. So from C1 I'm taking distance equal to CP, and I'll cut the arc with C1 on a line above P. Okay, so this point is giving me P1. So continuing with this method, so from C2, again line passing through 2 and just above first division, so this will give me P2. From C3 it will be on the center line, so this point will give me P3. From C4, line from fourth division on the circle, and that will give me P4. In the previous question we have divided that circle into 8 parts, so that's why at C4 we are getting the topmost position, but here we are divided into 12 parts, so I'll reach the topmost position after 6th division. So from C5 I have to cut here from the 5th division on the circle, so it will give me P5. Again for C6 I'll get the topmost position. That means from the bottommost point position P, now that P has reached to topmost position, so I'll name it P6. Then with 7, now the curve has followed the upward path, but after reaching the topmost position it will come down again. So with the next center C7 I need to come down. Okay, so P7, then C8, corresponding position of P will be C8 passing through the 8th division, then C9 again on the center line, so this is giving me P9. C10, line below the center line passing through 10th division, so this will give me P10. Then C11, again the line below, so somewhere here P11, and last with C dash it will coincide with P dash, which is already marked. Now we have marked P1 up to P11, P11 and P dash. So now the final step is to just join those points by smooth curve. Since we have got more number of points to join the curve, now here we can draw a smooth curve. So starting with P1, initially we can draw it by light line, but select the proper points which we have already marked. Some of the students initially mark all the points without giving the notations, then they'll get confused which point they have marked. So once you have marked one point, one arc, immediately you should name it, so it will avoid the confusion. If your freehand drawing is not good, you can use French curve. So nature of curve is similar to the previous problem, but only difference we are getting that curve along the inclined plane, so that's why it is like this. Now we can make that curve dark. Okay, so now after finishing this much, we have already completed the cycloid, so we can name the curve. So it is said name the curve, so we are naming the curve as cycloid, and then we have to show some dimensions like the diameter of the circle. So I can show the diameter here. For the circle the diameter is 60 mm, and also we can show the directing line, which is the circumference length. P to P dash. So we'll show it here parallel to the inclined line. The dimension line should be parallel. So this is pi d equal to 188 mm. Okay. Again, for further detailing, you can write this line as directing line and this circle as rolling circle. But only dark part in the entire solution should be the curve, only cycloid. Okay, so this completes the solution for this particular problem.